this video, we are going to look at the question, which is on number 9 in tutorial sheet number 8. So the question demands us to find the coefficient of friction. We've been given a beam, or rather a ladder, that is leaning against the wall. And then we have got the floor here, and then it is on this floor, leaning on the wall, which is, we saw the beam or the ladder has a uniform length of 5 meters. So A to B or B to A, that is the length of the beam. And then we're taught to say the mass of the ladder is 12 kg. Now we are taught to find this. Since this is a uniform ladder, the weight of the ladder is actually in the middle, right in the middle. So here we have the weight. So we have the weight of the ladder. And at the same time, since when this is about to slip, okay, there will be an opposing force that will be able to keep it from slipping off. And this is the friction force. If it is coming in this direction, the friction force will act in the opposite direction. At the same time, there will be a force that will be acting also upwards to keep this system in equilibrium, and this is Fn1. And at the wall here, we assume to say this one will be given to say this one, it is a frictionless wall. So we do not have any friction force here. So we just have the force that is reacting or that is keeping this in equilibrium, which is the Fn2. So this is point A. And the other thing that we have, so here we have the Fn, the Fr, and the Fn. So from this point, let us proceed. Let us see what we can do. So we know that the summation of forces in X must give us 0. Then in X we have Fr, which is this one, minus Fn2. Minus Fn2. This must give us 0. So that Fr will give us Fn2. But we know that Fr is equal to mu Fn1, which is this one. So if we replace Fr by this, we're going to have mu Fn1 is equal to Fn2. So dividing throughout by Fn1, even here, in order to remain with the mu only, we're going to have this and this will cancel, and we're going to have mu is equal to Fn2 over Fn1. Let us call this as equation number 1. But we also know that summation of forces in y must give us 0. So in the y direction, we just have this one, which is pointing upwards, which is Fn1. Fn1. Then the weight, which is W. This will give us 0. So this one, when weight crosses the equal sign, we are going to have F1. Fn1 is equal to weight. And weight, we know that weight is equal to mg. So plugging in the values, we know that the weight, the mass of the beam or the mass of the ladder is 12 kg, and the G is gravitational field strength, which has a value of 10 newtons per kg. So that kg and kg will cancel, and 12 times 120, we are going to have 120 newtons. So this is Fn1. So from this point, we are going to proceed as follows. We know that we have this system where we have this, we also have this and this. So we can use any of the 3 key identities to find the angle here. And find the angle here, theta. So we know that sine theta from Sokatoa, sine theta is equal to opposite over hypotenuse. Opposite is 4 meters over hypotenuse, which is 5 meters. So theta will be equal to the sine inverse of 4 meters over 5 meters, and that will give us 53 degrees. So theta here will be equal to decrease. And this one, since this is 5 and this is we are halfway, so from this point we have 2.5 meters, and also here 2.5 meters. And from this point, let me just erase this part. If we take the moment at point B, if we take the moment at point B, we have all the moments at this point will be 0. So we just have the moment for this and also the moment for this. And the summation of these moments must give us 0, so that this one and this one will be equal, because the anti-clockwise must be equal to the clockwise moments. So here we have this one. So this one times the perpendicular distance, we can just find this. So this one we can find from cos 53 degrees is equal to, so this is x over 2.5, so that x is equal to 2.5 cos 53 degrees. So this is the perpendicular distance to this. So we have this one, which is weight times x, must be equal to Fn2 times 4 meters. The weight of the room, it is 120 newtons times x, which is 2.5 cos 53 degrees, okay, which must give us 4m Fn2 over 4m, also over 4m. So that this and this will go, and we're going to have Fn2 45 newtons as Fn2. So from this point, we can proceed as follows. We know that mu from the equation that we found is equal to Fn2 over Fn1. Fn2 is 45 newtons over Fn1, 120 newtons. Punching this on a calculator, we are going to have 0.376, which will give us 0.38.